Hello again, our most valued student. My name is Confident and welcome to EduLearn Text 24-minute lesson. This is Mathematics N3, and in Mathematics N3, the following modules will be completed. In order for you to be ready by the end of the exam, you must know factors as one of the big modules, which involves algebra, exponents and logarithms, equations, word problems and manipulation, coordinate geometry, algebraic graphs and calculus, as well as trigonometry. By the end of these modules, you will be in a position to write your exams. Let us start by looking at factors. Under factors, we are going to look at factorizing by grouping. We're going to look at the difference of two squares. We're going to look at factorizing quadratic trinomial. We're going to look at the remainder and factor theorem. We are going to look at algebraic fractions, addition, subtraction, division, and multiplication. We are also going to look at completing a square. In this lesson, we are going to look at the two main parts, which are factorizing by grouping as well as difference of two squares. Before we go into that lesson, let us look at the type of calculator to use for your exam. The following type of calculator is the best calculator that I will advise you to use. It is this calculator FX82ZA Plus. This calculator will be able to help you, especially when you're calculating fractions, which are most complicated when it comes to other types of calculator. By the way, this is a cashier calculator. So if you can look for this calculator, it will be one of the easiest calculator and will make your exam or your practice of mathematics much easier. Let us look at the first part, which is factorizing by grouping, as well as we're going to look at what we mean by expanding for proof. If you look at the following problem, it says factorizing by grouping. Let us try to look at this problem. Now, if you have to factorizing means grouping things that are similar. For example, if you look at this problem, you have got the numbers. If you focus on the numbers, you have got a 4, you have a 10, and you have got 22. And the most common number between 4, 10, and 22, in other ways, the lowest common multiple or the factor, the highest common factor of these is a 2. 2 is the number that will go into 4. 2 is the highest number that will go into 10, and it will also go into 22. There is no other higher number that will go into all these numbers. The next thing common there, if you look, we are going to see that x is common, and x is common. So we are going to take out x. Now when you take out x, what is going to remain inside? You are going to say 2 divided by 2 into 4, or 4 divided by 2, you're going to go to get a 2. X divided by x, you're going to get a 1. Plus 10 divided by 2, which you factored out, you're going to get a 5. X divided by x, which is a 1, and y will remain because there is nothing common with y. Plus 22 divided by 2 is 11. X divided by x is an x, and then z will remain. This is what they mean by factorizing by grouping. If you expand as proof, you can expand and say 2x and 2 plus 5y plus 11z. You are going to find when you start to expand, it's 2x times 2, 2x times 5y, and 2x times 11y. 2x times 2 is 4x. 2x times 5y is plus 10xy, plus 2x times 11z is 22xz. Now, if you get 22xz, you will see that this is the same problem that you got in the first part. So this is a way of proving whether you are correct or wrong. Let us move on and factorize again the next problem. As an example, again, you look at the numbers, what is common, the highest common factor or the lowest common multiple, the highest common multiple, of 6 8 and 2. You're going to get that 2 is common. Also look at the unknowns. You have got A, you have got A, you have got A. So we can take out A outside. So it's 2A in actual fact. So now B is not common because there is only B in the first two and there is no B in the third one. Hence, you're going to say 2A divided by 2, it's a 4. A into A, it's a 1. And then B will remain. Plus 6 divided by 2, it's a 3. A into A, it's a 1. And B squared will remain. Minus 2 divided by 2, it's a 1, and A divided by A, it's a 1. Remember, a 1 will remain, not a 0. So that is what we mean by factorizing by grouping. Now, let us move on and quickly look at the other examples for what we mean by factorizing by grouping using the previous methods that we've just been using. What is common between the first thing you have to consider every time is look at the numbers. What is common in the numbers? You have got 2 as the highest common factor. Also, you can see that we've got x. Whenever you have got x squared and x, you take the one with the smallest power, and this x has got a power of 1, so we take that x. You divide now. 2 into 2, it's a 1. You can put a 1 if you want. And x squared divided by x, you will remain with x. Minus 4 divided by 2, it's a 2. X divided by x, it's a 1. So the answer becomes 2x into x minus 2. The next is an example again of factorizing by grouping. If you look at this particular example, you can see that x minus y and x minus y are common on both sides. Hence, if you take out x minus y, what are you going to remain with? Just have a look. If you take out x minus y, now 4. In other ways, this is what you're doing in actual fact. The first one is like you have got 4x minus y divided by x minus y, the one that it took out. So if you cancel this, you're going to remain with the 4 plus a squared x minus a, same thing. You have got a squared x minus y divided by x minus y. If you cancel that, you're going to be left with a squared. So this is what we mean by factorizing by grouping. You would have grouped in this case. Now, these are other examples that have already been done for you that you can look at. I want you to go through them slowly. You can pause the video and look at them, and there are also notes on the other side that will help you to remember how the factorization was carried out. For example, here, the first one, you are factorizing 10x minus 25. So if you're factorizing 10x minus 25, you can see there 5 was common, and you get 5 into 2x minus 5. This other one, you are factorizing 2x, x minus 3 plus 7, x minus 3, and you can see the red one, x minus 3 is common. So when you take out x minus 3, you're going to remain with 2x plus 7. So that is the answer. Moving on again, this is a problem that I want you to take note of. Look at this one. It says 2x, x minus 3 plus 7, 3 minus x. Now, I'm going to go through again this method much slower so that you can see what actually happened. But now, what you need to do is, whenever you're given this problem, let me write it again so that you can see what actually happened. So this is the problem. It's 2x, x minus 3 plus 7, 3 minus x. Now, I want you to take a look at the following x minus 3 and 3 minus x. You can see that the two look similar, but they are different because in the first one, x is positive, and in this case, the second one, x is negative. In the first one also, it's minus 3, and in the other one, it's a positive 3. Now, if I can show you something here, for example, suppose I'm given 3 minus x, and I want it to become x minus 3. What you can do, the trick there is to take a negative 1 outside. If you take a negative 1 outside, you say 3 divided by minus 1, you will have minus 3. And minus x divided by minus 1, you will have a positive x. Why? Because a negative and a negative, when you divide them, you get a positive. To prove that your answer is correct, if you are given minus 1 minus 3 plus x, and I say expand, minus 1 times minus 3, it's a positive 3, and minus 1 times an x is minus x. So you can see that you get your 3 minus x. Hence, in this particular problem, when you are given 2x and x minus 3, now you are saying plus 7, you take out that negative 1 we did in the previous example. When you take out a negative 1, this will change also to become x minus 3. If it becomes x minus 3, so what we have now is we have got 2x and we have x minus 3. Now, plus 7 times minus 1 becomes minus 7, and then you've got x minus 3. Where did I get x minus 3? Remember, minus 3 plus x is same as x minus 3. If you continue, now what is common? You can see that x minus 3 is common. Now, inside the brackets, it is common. So we're going to take out x minus 3 as something common. Now, what is remaining? When you take out x minus 3, you're going to remain with 2x here. Minus, if you again take out x minus 3 in the second one, you're going to remain with minus 7. And this is the final answer. If you expand it, again it will take you to the previous version. Hence, this is what I mean by saying, whenever you're given an x minus 3, you must just put a negative sign, automatically it will change. So, you will look at this problem, it is put in a better explanation. Look at the side notes and then it will help you to see exactly what happened. Let us look at the next problem. It says 5y minus 2 minus x 2 minus y. What I wanted to focus on is look at the different colors of y minus 2 and look at 2 minus y. You can see again, using the previous version that I showed you, that 2 minus y, if you take out a negative 1, you are going to have minus 2 plus y. If you rearrange it, minus 1 is same as y minus 2. So now we have got a y minus 2, which is equal or similar to the y minus 2 of the first bracket. That is the trick, and the rest is something that you can follow and you factorize like normal. Let us look at another problem whereby an interesting part on the grouping by like terms, that is the same thing as factorizing by grouping. Look at the problem that I have here. It says 28ab plus 2cd minus 8ad plus 7cb. There are two versions in which you can approach this problem. Here I'm going to discuss those alternatives, and then I'll show you the quicker method that has already been worked out. But the quick thing you must ask yourself here is, whenever you're given such a problem, for example, we can try to focus on the first two and ask ourselves, what is common in the first two? And then you focus again in the last two and ask yourself, what is common in the last two? For example, if you can see in the first one, we've got 28ab plus 2cd. The only thing common is 28 and 2, in which you can take out 2, but a and b, there is nothing common. Also, in the next one, if you can look at it, we have got 8ad plus 7cb. There is nothing actually common in the second one. Hence, you can try to regroup in another way, because it seems the first two are not common. Another way of grouping it is, maybe if we take this 28ab and group it with 8ad. What is common? The numbers 28 and 8, we can factorize that, as well as ab and ad, something is common there. And we can also look at 2cd and also group it with 7cb. What is common there is C and C on both sides. So if you look at that, I can rearrange it like this. It will give you 28ab minus 8AD plus 2CD minus 7CB. Now you can see that there is something common in there. What is common in the numbers? You have got 4, because 4 can get into 28 and 8, as well as A as the unknown. So you're going to have 7 in the first one. You're going to have 7B minus 4D. If you have got 7B minus 4D, the next one again is to look at what is common in the next fraction. You can see that what is common there is C. Now, if we can just take a positive C, I want to see what we'll have. If you take a positive C there, actually I made a mistake on the first one. I took out a 4, and 4 and 8 is not a 4. Actually, 4 and 8 is a what? Is a 2. 8 divided by 4, it's 2D. So now let's move on. I've taken out a C in the other one. What I will remain with? I will remain with 2CD into C. I will remain with the 2D minus 7B. If you look at these two, again, look at that trick again, whereby you have got 7B minus 2D and 2D minus 7B. By putting a negative in the other one, it will make it similar to the other one. In other words, I'm saying you can write it like this: 7B minus 2D, and then you say minus C. The moment you say negative C, the signs will change in the following bracket. So you're going to have minus 2D plus 7B. If you rearrange it, you're going to have 4A, 7B minus 2D minus C, and then you're going to start with a positive 7B minus 2D. Now you can see now that what is inside the bracket is the same, and when you write it finally, you're going to have 7B minus 2D. Outside the bracket, you have got what is outside the bracket, 4A and minus C. So you will have 4A minus C. Then it means you have factorized that problem. As I said initially, these are the two different methods of the same problem. Just pause it in this slide, look at the notes on the other side, and try to understand exactly how the following were grouped together. It will give you an understanding. So this is the first method that is given. Just pause and look at the solution, and also look at the side notes. The second method again is this one. I think this is the method that I did previously. You pause the slide and again look at it. It will give you more hints. Now, when you have factorized that, you can actually prove whether your method is correct or wrong. You can prove if your method is wrong or correct by expanding the answer that you got. For example, remember we got 4A minus C, 7B minus 2D. By expanding, you will discover that you go back to the same problem that you started with. You can check that on your own. Another way of factorizing again, let's look at the problem here. It says xy minus x squared minus x plus y. There is something that you need to be careful of here. Just check how this method was done, whereby in the first one, x and x squared were common. In the second one, there is nothing common here between x and y. And the only hint to tell you is that when there is nothing common, you must know that 1 and 1 is appearing on both sides. So you take out 1 as common. So when you take out 1 as common, you can work it out and it can give you that particular answer. We are now moving on to look at the difference of two squares. Now, what does the word difference means? Difference means minus. So it's like you're subtracting. So that's why difference of two squares will involve things like 13 squared minus 11 squared, or 260 squared minus 258 squared. Difference of two squares. The square is the one that you are having there on top. Now, using your calculator, can you try to quickly calculate 13 minus 11 squared and 260 squared minus 258 squared? When I punched my calculator, This is what the answer gave me after punching the calculator. Now let us work it out without using a calculator and see what we're going to get. Without using a calculator, you can write this one as 13 minus 11. You write it as it is. Pretend you are not seeing these squares. You will see 13 minus 11. You write again another one, 13, but this time you put a plus 11. What is 13 minus 11? You are going to find a 2, and 13 plus 11, you are going to see that it's 24. And 24 times 2 is equal to 48, which is the answer that you got. Again, pretend you have got 260 squared minus 258 squared. Pretend you don't see the squares, those that are settled in red. So you are going to see 260 minus 258, and the other one will be 260 plus 258. If you work it out, here you are going to get a 2, and the other one you are going to get a 518. If you multiply 518 times 2, you are going to get 1036, which is the previous answer that you got when you did your calculating. So this is called the difference of two squares. Now let us apply it in this case. When you are given x squared minus y squared, what you must remember is that you write it as x minus y, and then you write the other one again as x plus y. That's how you solve a difference of two squares. When they give you the next one, which is x squared minus 64, the first thing is to write it as x squared minus 64, by the way, is 8 squared, so that you change it into a difference of two squares. Then you're going to forget about those squares. You can see that there is 8 minus x, and the other one you are seeing that it's x plus 8. Remember, the other one is negative and the other one is positive. Look again at this slide. It will help you also to remember some of the difference of two squares that they usually ask. Here is x squared minus y squared. We did it. X squared minus 1. Remember, the trick of 1 is that 1 is 1 squared. So look at the notes on the other side again as a remembrance. The other one is 16y squared minus 4. 16 is 4 squared, 4 is 2 squared, and you can also use that so that you can see how they solved it. Now let us look at this difference of two squares here that is hidden. The hidden part in this difference of two squares is, yes, we have got a squared and minus b squared. But look at it, 50 and 8, there is nothing common, but it is. If you take out a 2, you can start to see now that if you take out a 2, you remain with 25a minus a squared minus 4b squared. Now, taking out again a 2, what is 25? 25 is 5 squared, a squared. What is 4? 4 is 2 squared, b squared. If you look at it, now you are going to have a 2. Now forget about, pretend you don't see the squares. This is a 2 squared. Pretend you don't see anything on the squares. What you're going to have is 5a minus 2b, and also the other one is the same thing, 5a plus, in this case, plus 2b, because a difference of two squares, the other one is negative and the other one is positive. Now I want you to remind something so that you don't find yourself making some errors. If they give something like this, they say x squared plus y squared. This is not a difference of two squares. This is not x minus y, x plus y. It is not, because this is a sum of two squares, not a difference of two squares. We have come to the end of our 24-minute lesson. We are going to continue with the difference of two squares in the next lesson. Thank you.